population one with the depth one that we just did, it's not realistic that this is going to happen. But for the time being, to introduce you to the idea, if you're trying to solve an exponential equation where the variable is in the exponent, without any other resources, we try to rewrite the bases so that they're the same. So what I mean by that is 8 can be rewritten as 2 to the third. And 32 is the same thing as 2 to the fifth. And then you're going to have to use some exponent rules, which we kind of reviewed yesterday. When you raise a power to a power, what do you do with those powers to come up with the new exponent? Multiply, so that's 2 to the 3x equals 2 to the fifth. Once you have the same base on both sides and it's all by itself, so 2 to a power equals 2 to a power, the bases of 2 cancel. So essentially we're just left with having to solve this equation, 3x equals 5. Divide both sides by 3, x equals 5/3. How can I rewrite 9, Angie? Something that has a different base. What to what power gives me 9? 3 squared. So 9 replaces with 3 squared, and we still have a 2x plus 1 exponent. And Morgan, 27 is what? What to what power? We're trying to get common bases. So the base on the left is a 3, so our goal is to hopefully get a 3 on the right. 3 to the third, good. So same idea here, we have to follow some exponent rules. Power to power means multiply. You just have to be a little bit more careful here because you have to, when you multiply power to power, you have to distribute 4x plus 2. And now we have 3 to a power equals 3 to a power, so we can drop, and all we're solving is 4x plus 2 equals 3. Subtract 2 from both sides, 4x equals 1. Divide by 4, x equals a 4. How can I rewrite 125? Lucas B. What to what power will replace 25? Say it again. 5 squared is 25. I want 125. I'll give you a hint. You have the right base. It's 5 to something. Five to the third, very good. So 5 to the third to the x. This right side is trickier. And this is going to happen more times than not, more times in Algebra 2 than it did in Algebra 1. 1/25. And use your left side as a hint. Your base on the left is 5. 5 to what power gives you 1/25? Corey? 5 to the negative second. Fractions are taken care of by negative exponents, right? Because that's the same as 1 over 5 squared, which is 1 over 25. And then that's to the 4 minus x. So on the left side, we get 5 to the 3x when we multiply exponents. On the right side, we get 5 to the what power, Owen? The right, yeah. What am I supposed to be, what up, this, and what am I doing with the two exponents when I raise a power? Nope. Power to power u. Yeah. So you might want to write that down. Power to power means multiply. So what would the new exponent then be, Owen? Plus 2x. Good. So I have 5 to a power, 5 to a power, drop it, solve the equation that's left. I'm going to subtract my 2x over, and I'm done. Okie doke. Exercise 4, the left-hand side has 2 to a power. 2 cannot be written any smaller. 2 is 2. So that's 2 to the x squared minus 3 equals, now how can we rewrite 64? 2 to the what, Vince? Two to the x squared minus 3 equals 2 to the 6th. 2 to a power equals 2 to a power. Cancel your 2's. We have x squared minus 3 equals 6. This is the first time where when we've canceled our bases, we have a quadratic. The good news is we don't have to do the quadratic formula. We don't have to do factoring because there's no x plain old x term. We can just get x squared all by itself by adding 3 to both sides. We get x squared equals 9, and we solve by square root. So x equals, anytime you take the square root of both sides, remember your plus or minus. Good? Okay. Number 6, same skill, different way of asking it. At what x coordinate will this graph, 25, y equals 25 to the x minus, what does that look like to you? An A, right? It looks like an A to me, but I feel like that's not right. Oh, no, it is an A, because there are A's in the answer. Okay. Intersect the graph of y equals that. So when you're looking for where two graphs intersect, this is otherwise known as a system. Oh, you are on fire. Good job. Otherwise known as a system. So this is an easy system because they're both y equals already, so we can just set them equal to each other. 25 to the x minus a equals 1 over 125 to the 3x plus 1. Get a common base on both sides, so how can I rewrite my 25, Eric? Five squared, and my keep going with the 1 over 125. It's 5 to some power. 5 to the negative third, correct. Fractions create negative exponents. Power to power multiply. So 5 to the Faye, what's this exponent going to be? No, that's an A. You thought it was a 9, huh? 2A. And what's this exponent going to be, Natalie? Say it again. Did you say X? Okay, good. So 5 on both sides, cancel. And we're solving for what variable? X. So get all your x's on one side. Get all your non-x's on the other side. And then divide by 11. So our answer is 2. Looks a little different, 2a minus 3 as opposed to negative 3 plus 2a, but same thing. Your 3 is negative, your 2a is positive. 2. Good? Oh boy, what is going on here? 2 exponential curves. This is so Common Core-ish, right? It's gonna, the skill that we just learned is gonna be hidden in a monstrosity of an explanation and a beautiful picture, and half of you panic and don't think you can do it and stop, or get in your own head and don't do anything. My job is to train you to stick with it, because it will be something you know how to do hidden in a bigger problem. So 2 exponential curves, y equals 4 to the x plus 5 halves, and y equals 1/2 to the 2x plus 1 are shown. I would ask you which is which, but they already labeled it. But how would we have known that this is the y equals 4 version, and this one's the y equals 1/2 version? Chris Brooks. Decay, right. Decay, growth, and there's your growth, there's your decay. But they labeled it for us. That was nice of them. They intersect at point A. A rectangle has one vertex at the origin, that's there, and the other at A as shown. So A is the point of intersection of our 2 curves, agreed? So can we pretty much do the same thing and figure out what the coordinates of that point are? I haven't read the rest of it, but I'm pretty sure we can find the coordinates of that point simply by solving the system. Where does this curve intersect this curve? So let's do that. Let's set them equal to each other. I'm just going to go way down at the bottom because it doesn't really explicitly ask us to do this. Alexa, how do I rewrite 4? And how do I rewrite 1/2? Did you already say that? Or no? Okay, Kate, how do you rewrite 1/2? 2 to the negative first. Very good. Power to power rule means do what, Owen? And so this is going to become what? Left side. Right, 2 times 5 halves is 10 halves. 10 halves is that whole number 5. And the right side becomes 2 to what power, Mike? Cross out your common bases, solve for x. So I'm going to add my 2x to the left, subtract my 5 to the right. I get 4x equals negative 6. X equals negative 6/4 or negative 3/2. So that gives me the x coordinate of my point, negative 3/2. How do I find the y coordinate of my point? Jason. Yeah, either one. Just plug in an x of negative 3/2 to figure out what the y coordinate is at that moment. So I'll do the 4 just because full numbers are more fun for me. 4 to the negative 3/2 plus 3/2. Oh, is that 5/2? Plus 5/2. What's negative 3/2 plus 5/2? 2/2, which is 1, which will give you 4. So the y coordinate is 4. So this essentially then goes on to say we want to find its area. How do you find the area of a rectangle? Length times width. How does knowing this coordinate help us know the length and the width? Lucas. We would probably go with the x first, because normally to plot a point, you use your x coordinate, which is -3/2. So this length must then be -3/2. So we have, I can't really see it unless I get rid of this work, sorry. So this length is -3/2 to get over, and then your y coordinate tells you how far to go up, so that must be 4. So our area is just length times width. So area equals 4 times -3/2, which is -12/2, which is -6. Now, does a negative area make sense? Right, so even though the coordinate is negative, the length itself is technically always a positive length, so your area would be, and that's just kind of a logical extension, the area would have to be a positive number. So we're not doing it separately, but fundamentally, what do we need to know about a rectangle to find its area? The length and the width is what they were looking for. How would knowing the coordinates of point A help us find the area? Because the x-coordinate gives us the length and the y-coordinate gives us the width. So they kind of walk you through it. The Common Core would just say, this, what's the area? And you kind of have to piece that together. Okay? Anybody hate Eric? I have your test. Here's my test. Take over, please. And then your homework's coming around. Do you remember doing the method of common bases in Algebra 1? You don't? I know, it was a long time ago.